and the pod can be triggered by cluster AutoScaler, and then the cluster AutoScaler will trigger AutoScale, which is Alibaba Cloud services we call AutoScale, and the AutoScale will create a new ECS and add this ECS into the cluster, or the pod can through virtual cooled AutoScaler that is developed by Alibaba Cloud, the component, to add more pod, to create more pod, and this pod running on ECS. So for HPA, we know in the community version Kubernetes, it's by default it supports resource metrics such as CPU and memory. So also we enhance the HPA ability to add the other external metrics. For example, the QPS, the latency. Okay, I will show you what is this later, and in the demo I will show you. Okay, so for the HPA, it's very easy to enable it. Just run this command or did something on console. Okay. So what is HPA? HPA is he has some it includes the 3 stacks. So for the metrics, like I mentioned, we provide the resource metrics and external metrics. So for HPA, that is one, you can understand that is one of the component, one of the item, or one of the deployment. Okay, so HPA component will absorb metrics. Okay, when absorb the metrics, that will change the number of replica, of deployment replica, and the scale number of pod to add or remove the pod. Each slide I have a link that point our official document that show how to do the HPA step by step. It's very clearly. So what is a cron HPA? Let's see this diagram. This is a workload pattern. This application is we see the pattern. So each day type they have a high traffic, and when in the from the evening, maybe from 12 o'clock to 8 o'clock, let's have a low traffic. So this is a pattern. So if your application have a pattern, have some regular pattern, have a consistent pattern, and you know what the pattern is it, so you can use cron HPA to make your application to scale down or scale up. So what is cron HPA looks like? Just define this YAML file to define the kind it's cron horizontal pod AutoScaler, and to define this cron HPA scale the target reference to which deployment, and to define the scale down and the scale up schedule. For example, this code means it will scale down every 30 seconds of each minute. It will scale up every first second of each minute. So the scalar, how to write the scalar, we can reference this table. So let's include seconds, minutes, hours, a day of month, and a day of weeks. Just as the first word is second, and the space, and the second word is minutes. And that's like that. Okay. Next, let's see what is a cluster AutoScaler. The cluster AutoScaler means if we have pods are in pending state, that will trigger cluster AutoScaler component. And the cluster AutoScaler will add the new nodes through AutoScaling, which is Alibaba Cloud Services. And the new node will be launched. And the pod, the pending state pod, will schedule themselves to this node. Okay. So this is a document link. Okay. I think maybe after meetup, maybe Jesse can send this slide to you to find more information. Yeah.
Sure.
So for cluster AutoScaler, we have two models. One is standard model, and another is a Swift model. What is the difference? The Swift model will save 67% time than standard model. So how is it work? It's like I said, AutoScaling will in charge of add or remove more nodes. So for AutoScaling, that we have a Swift pool. Okay, this Swift pool will store all of the node. Okay, so AutoScaling will recover node from the pool. If the pool do not have node, that will create new node. Okay, and when scaler scale down, that will recycle the into Swift pool. Okay, or scale up node. Okay. So what is the virtual node AutoScaler? For example, this is a Kubernetes cluster. So that have a normal pod running on ECS, but have some, for example, have some temporary job or temporary workloads that it's not a long time to running. So we can make these workloads running on virtual node. For example, for CI/CD pipeline. So just for CI, during the CI, we can make the CI work on this ECI, and when CI finished, when CI done, that can be removed the code automatically. Okay, so that is very flexible for our application to do scale to virtual node. So what is external metrics? We know by default, Kubernetes provides the resources and metrics, CPU and memory. But sometimes just the CPU and memory, just 3 CPU and memory to do AutoScale, that is not enough. For example, maybe we want to make this our website QPS or our application latency. So how we can do? So now we support the log service ingress some metrics to do AutoScale, or SLB load balancer some metrics to do AutoScale, or cloud monitor, or it has Sentinel some metrics to do. For example, this is log services metrics. So for log service metrics, it can be SL ingress QPS, or latency average, or latency P 50. something like that. Okay. So I will show you how is it work. Okay, so the basic concept we introduced finished. So now I will show you how is it work. What's the demo here?
Lishan, sorry, there's a question here. Is ECI available in Indonesia region? If compared to ECS, which one is lower cost?
Okay. ECI available now in Indonesia region. Let me show you what is. So where is it? See, let's take container list. We can see that in Indonesia it's available. So it's available in region Indonesia. Okay, this is the first question. And compared to ECS, which one is lower cost? Okay, if your application running in the whole day and the whole night. For example, more than every day, the 24 hours your application will be running. We suggest you are using ECS, that will be lower. But if your application running less than 8 hours each day, we suggest you are using ECI, that will be cheaper than ECS. Yes, that doesn't answer your question?
Yeah, you can go ahead, Lishan.
Okay.
Oh, there's one more question coming up. How does the performance, sorry, Lishan, how does the performance, I think still from Benny, he's asking about the performance of ECI versus ECS.
So your performance means scale the time, how many time you spend for scale, or which the performance which could you explain with the performance your means is scale up, scale down, how many times you take, or other performance? Okay. So you can leave your message, and when I see your message, I will answer your question.
Yeah, go ahead, Lishan.
Okay. So now we go back to ACA, Container Service Kubernetes. I had created a cluster already, and now I already push my image into a cloud registry. Okay, and how to use the cloud registry, the next session will cover this topic. Okay. And now I have this registry, and I already have some Docker image version in this registry. Okay, and I have some deployment been deployed. So I will show you the 3 demo. One is scale HPA pod demo. That is metric. That is from resource metric, and just add more pod in this cluster. And the next demo is scale cluster. That means we go back to the PPT. That is a cluster AutoScaler. Okay, here cluster AutoScaler. And the next one is virtual node. This demo is mapping here virtual node. How to scale the pod running on virtual node. Okay, so now let's go to here, go to scale HP. This YAML file looks like okay, this is YAML file. So I define the deployment, and I define the service. Okay, and I define the ingress. Okay, so when I click this create, that will be deploy this pod on this deployment, and will create the service here, and will create ingress. Here, and when I access this ingress, it's very example. It's very simple application, just type hello world. Okay, and this can be accessed. So now let's see how to do the AutoScale. Now I define this deployment have 2 pods. Okay, and for this we can see how 2 pods is be running, and this is HPA can be defined here. So I already created the HPA. Is if CPU utilization more than 50%, that will be scale up, and the max replica is 10. So that means if the replica to 10, that will not scale up. Okay, and the minimal replica is 2. That will scale down to 2. That will not scale down. Will not keep scale down. Okay, now we can see the CPU is 0% because I'm not I'm not access the application. So now let me can you see my clearly? Here is better. Let's see how many pods be running, and this pod is this pod. It's the same. That means the same. You can see scale HPA pod demo blah blah. Okay. And now we go into this pod and to simulate to stress the CPU to make the CPU be higher. This has some more. We replace snake into this pod. This command means we log in to this pod, and you can understand that it's logging to it's seamless with logging SSH to ECS, but it's not inside. It's a pod. Okay, and in this pod, I already installed the StressNG. StressNG is an open source tools to make we can do the stress testing via StressNG. So now we running StressNG on C1. Okay, that will stress the CPU. And when we go to the port, wait a moment. When we go to now we can see the CPU is up to 16%. 8 minutes. That will keep going up. During this time, let's see some questions.
Oh, there's no question. Yishan, go ahead.
Okay. Okay, now CPU is more than 100. Let's see what happened in port. We can see now how other ports be creating, and this is how some pods is be running and some pods not running. We should waiting. Okay, and when we go back to this port to the console, we can see all of the pods be running. So that's the scale HPA pod, and the max number is 10. Okay, and when we go back to the command, we can see all of the pods will be running. Okay, so that is a resource matrix with stress to CPU, stress test to CPU, and the CPU is higher than 50%, and that will scale up. So now we stop to stretch, and maybe when we need some time, maybe 5 minutes, that will scale down, automatic scale down, and the pod will be delayed. Okay, later we will see that. We will check that. So now we can see how it's running. Okay. So next demo, let's see the cluster. The cluster AutoScale here. And here cluster AutoScale. And this document shows how to do cluster AutoScale step by step. Yeah, and this document say how to do the HPA step by step. I say that like I demoed to you. Okay, so now go to scale AutoScaler. The scale AutoScaler YAML file looks like it is. Okay, because I want to, this is a demo, so I define the request the CPU is 2 core. just make a demo easy. So in the general CPU just 1 or just 0.5, it's okay. So like this demo, I define the CPU is 258. So why I define this? Because I want to add more ECS. I want add more ECS into this cluster to let us to look at what is the cluster scalar. Okay. So when we create that deployment, we'll deploy the scalar cluster, and how to do the cluster AutoScaler. Before that, in this cluster, we should configure the AutoScaling here, AutoScaling, and to hide the scaling group. Okay, the scaling group, the regular instance or the regular instance or GPU instance or principal instance. Okay, for regular instance, like I mentioned, it have two models, standard and Swift. Okay, do you remember the Swift model? This is Swift model. Swift model will save 67% time. Okay. And the other is is create a cluster to define which VPC, which vSwitch, and which ECS, and do you need to mount data disk, and QPR, and scaling mode, and the ECS label of you need attained to your node. Okay, so I have created AutoScaler already. So this scaling group, I define the max instance is 10. So that means the new ECS will create a 10 instance that will not keep creating. Okay, and here define the defer, scale for the cooldown, how many minutes. So by default, that is 10 minutes. Okay, so now because for demo, so I make it 1 minute. Okay, when we configure down the scaling group, and when we deploy our application or deployment, okay, for this demo, I will use the external matrix. Do you remember which is the external matrix? The external matrix is I will using log service as far as ingress latency. So the YAML file, let's see the YAML file. Okay. This is for complex. This YAML file. Okay, this YAML file. This YAML file is I define the HPA horizontal port AutoScaler. And the mean replica is 1. The max replica is 8. Okay, and to define the matrix is external. the name we are using SRS ingress latency P99. Okay, and define the SLS project and the SLS log store. And the service name, pattern is namespace /svc port. Okay, and this value means if the latency P99, the value is more than 5 milliseconds, that will scale up. Okay, let's go back. Let's go to log service, or we call SLS, to see the value now. How to got the latency. When we create a Kubernetes cluster, if you select create a log service automatically, that will create a project in log services, and that will provide the modern 10 dashboard by default to make you very easy to see how many PV, UV, and average latency, and other value and number. So now, because I'm not access the website, not access the services, so all of the number is on. And now we open the refresh. Okay, and now we simulate access the service. Okay, so which is the service? Like I mentioned, when I deploy the deployment and index YAML file, I define the service is here, and I define the ingress is here. So when we access this application, okay, that will access this application. You know, this application, I make this latency for more than 5 seconds because I want to do the demo to make you know what it looks like. Let's see these services is very quickly to see the hello world, but this application we can see have some latency, making 1, 2, 3, 4, 5 minutes, 5 seconds. And see the words. Okay, so that means when I access the application, it sure latency more than 5 milliseconds. Okay. Now let's simulate access these services. Okay. Go back to the SR, we can see no P25 latency is more than 5 milliseconds, and we go back to this deployment. Okay, now it's 3 nodes we create. We can see that the nodes will be created. Okay, we can see the nodes will be created, and the pod will be running in this worker. So how is it? Principle looks like this here. So I have a Swift pool. That is node is stopped. It stopped. It stopped before. And this is stopped. And when traffic coming, that will cluster AutoScaler will trigger AutoScale to recover the node from pool. Okay. And now we go back to the pod, to the node. this scale. Now we can see the pod is maximum is 8. Remember, I said the number the maximum is 8. So all of the pod will be running. Okay, and this pod running on new instance. Running on the new instance is not existing instance. Now we stop stress testing. Later, the nodes will be stopped. And do you remember this demo? We make this pod to 10 quantity to 10 pod, and now we stop the stress testing, and the pod reduced to 2, reduced to normal number. Okay. Okay, and later let's we check this pod. Okay, this pod will reduce to one replica. Okay, so next one, let's see the skill virtual node. Skill virtual node means have some pod running on instance. For example, this pod running on instance or this pod running on instance. But now I want to some pod, want to some application running on virtual node and scale up in this virtual node. Okay. So how to do that? The first in here app catalog, we have a virtual node. We provide this helm chart. Or you can understand that is add-on. Okay, and just create will be installed in your cluster. And before that, you should define the ECI. The virtual node running on ECI based on ECI, and the pod will running on ECI. The ECI region will switch and the secret group, your access key and the secret key. Okay. So this the region will switch and the security group you can port from your common node, your normal node. Okay, when you open this node, you got the now here. You could got your switch here and the security group here, and you could got the number, the instance ID. Okay. And when we install that component in your nodes list, you will see have a virtual node ECI. Okay, so that means it's already installed in your node pool. And now we set to schedule. That means pod can be scheduled on this virtual node. Okay, so in this virtual node, you can using a demo with the resource metrics or with external metrics. Okay, and when you create this, if you are interested, you can go to ECI console. Okay, when you create a new, when you have a new virtual node running on ECI, you'll be able to see the code running on here. Yeah, it's the same. Okay. So now I have deployment with demo for the virtual node. It's deployed here, scale virtual node. And now, so that means if the virtual node, the application running on the virtual node, if it's not work, you can scale down to 0. And if you want to make it work, you can scale up. So now I scale by manual. Okay, the manual to 5. Okay, wait a moment. When we go back to the pod, we can see all have 5 pods be creating, and now it's pending status. And when we go to ECI to see, we can see have 5 pods running. And in the pending status, and wait a moment, we go back to see how 4 is running. Okay. Okay, and this is the file called be running. Okay, so in the virtual node, you also can use resource metrics to scale, or using external metrics to scale. It's the same. And when we see ECI, we can see the file container be running. Okay. Yes, so I think that is all the demo and the introduction. Let's see, do we have some questions?
Yeah, Lishan, there are some questions. Let's check out here. In terms of speed of adding new resources for pods to run, which method is fastest?
Okay. The ECI is master. Let's see. Let me show you a number. Here. Okay. For the AutoScale, make it be bigger. If 500 nodes in the standard model will take 2.5 minutes. Will take 90 seconds in Swift model, and will take 30 seconds on ECI. Okay, did that answer your question, I think?
Sure. Next question is Benny question. In the scaling group, there is no ICS. I'm not too sure whether you're able to.
ICS? What means ICS?
Okay, we take this down. Later, Benny is also in our Dean Talk group as well. No worries. We can take this offline. And there's another question from Dean Talk group. Is how stable is ECI as compared to ECS?
How stable? How stable? What's mean how stable?
Okay, this is also from our Dean Talk group. Never mind, we can take this offline. Lishan, can you let me share my screen? If you can. Yes, if you have any questions, feel free to just either you can leave your questions in Q&A or chat. Okay, and we have more questions coming up from the Dean Talk group, Lishan.